Alright, here's our last example of L'Hopital's rule. And again, I would start with direct substitution. And when I plug a 0 in there, I've got 2 times sine of 0. So 2 times 0 minus sine of 2 times 0, which, guess what, is 0. So I've got a 0 on the top. And in the bottom, I'll have a 0 minus 0. So a 0 in the bottom. So indeterminate form, that would tell me, hey, use L'Hopital's rule. So L'Hopital's rule says the derivative of the top. So the derivative of our top would be 2 times cosine x minus, and the derivative of sine is cosine, leave the baby alone. Since this was a composition, I've got to multiply by the derivative of the inner function, and the derivative of that inside is just 2. All over, the derivative of x is 1, and the derivative of sine x is cosine x. So we got our derivative. Now let's plug in a 0 and see how it works now. 2 times cosine of 0. So that's 2 times 1 minus cosine of 2 times 0, which is 1 times 2, all over 1 minus cosine of 0, so 1 minus 1. And what you're going to notice is we still have 0 over 0. So another indeterminate form. So let's use L'Hopital's rule again. So the derivative of 2 cosine x would be the derivative constant multiplier with a 2, and the derivative of cosine is negative sine x. And then over here I've got minus, the derivative of cosine is negative sine. Leave the baby alone. And there's a constant multiplier of 2, I can't forget that. And then the derivative of the inside function is also 2. So multiply by the derivative of the inner. Chain rule. All over 1 minus cosine x. Oh, the derivative